In the grand tapestry of human exploration, few chapters have unfolded as rapidly and as astonishingly as the search for exoplanets, worlds orbiting stars beyond our sun. Just a few decades ago, the idea of discovering planets outside our solar system was a subject for science fiction and theoretical debate. Today, exoplanet exploration stands as one of the most dynamic and transformative fields in modern astronomy, with thousands of distant worlds cataloged and many more awaiting discovery. This explosion of knowledge has not only expanded our understanding of the universe, but also reshaped our perception of our place within it. The story of exoplanet exploration begins with a sense of wonder and curiosity that has animated humanity for millennia. For as long as people have gazed up at the night sky, we have wondered if other worlds, perhaps like our own, circle the myriad points of light scattered across the darkness. For centuries, these questions remained unanswered. The planets in our own solar system, the only known examples of worlds beyond Earth. Everything changed in the late 20th century. In 1992, astronomers made a stunning discovery. 2 planets orbiting a pulsar, the rapidly spinning remnant of a dead star. Though these worlds were unlikely to host life as we know it, their existence proved that planetary systems could form in a variety of environments. Then, in 1995, a breakthrough came with the detection of a planet orbiting a Sun-like star, 51 Pegasi. This exoplanet, dubbed 51 Pegasi b, was a gas giant orbiting extremely close to its star, a so-called hot Jupiter. The discovery was a revelation. Not only did it confirm that planets could exist around other stars, but it also shattered preconceived notions about what planetary systems could look like. The floodgates had opened. Armed with increasingly sophisticated technology and driven by boundless curiosity, astronomers began hunting for exoplanets in earnest. The methods they employed were ingenious. The radial velocity method, which measures the subtle wobble of a star caused by the gravitational tug of an orbiting planet, allowed researchers to infer the presence of unseen worlds. Meanwhile, the transit method revolutionized the field by detecting the slight dimming of a star's light as a planet passes in front of it, offering a direct way to spot exoplanets and measure their sizes. The launch of the Kepler Space Telescope in 2009 marked a turning point. Kepler's mission was bold yet simple: to stare at a single patch of sky and watch for the tiny periodic dips in brightness that signaled a planet crossing in front of its star. Over the next several years, Kepler's unblinking gaze yielded an astonishing bounty. Thousands of exoplanet candidates emerged from its data, ranging from scorching, gas-shrouded giants to rocky worlds not much larger than Earth. For the first time, astronomers could begin to tally the population of planets in our galaxy, and the results were staggering. Planets, it seemed, were not rare cosmic quirks. They were everywhere. This explosion of exoplanet discoveries transformed our understanding of the universe in profound ways. We now know that there are more planets than stars in the Milky Way, and that planetary systems are as diverse as the stars they orbit. Some exoplanets race around their stars in a matter of hours, while others take years or even decades to complete an orbit. There are planets with searing day sides and frigid night sides, worlds shrouded in thick atmospheres of hydrogen or methane, and even so-called rogue planets that drift through space untethered to any star. Perhaps most tantalizing of all are the discoveries that hint at worlds similar to our own. Among the many exoplanets cataloged are those that reside in their star's habitable zone, where temperatures could allow liquid water to exist. Some of these planets are rocky and roughly Earth-sized, raising the possibility that they might harbor conditions suitable for life. The search for such worlds has given new urgency to the age-old question: are we alone in the universe? The rapid pace of exoplanet exploration owes much to technological innovation. Space telescopes like Kepler and its successor, TESS, the Transiting Exoplanet Survey Satellite, have been pivotal, but ground-based observatories have also played a crucial role. Advances in spectroscopy have allowed astronomers not only to detect exoplanets, but also to begin probing the compositions of their atmospheres. By analyzing the starlight that passes through or reflects off an exoplanet's atmosphere, researchers can search for the telltale signatures of water vapor, methane, oxygen, and other molecules that could hint at biological processes. With the recent launch of the James Webb Space Telescope, the field stands on the cusp of another revolution. Webb's powerful infrared eyes are poised to peer deeper into exoplanet atmospheres than ever before, potentially identifying chemical fingerprints that could point toward habitability or even life. Meanwhile, planned missions and next-generation observatories promise to expand the search, targeting smaller, cooler stars and probing the environments of Earth-sized planets. The excitement surrounding exoplanet exploration extends beyond the scientific community. The public has embraced the search for other worlds, inspired by the notion that planets like our own may exist within reach of future generations. Exoplanet discoveries have forced us to reconsider long-held assumptions about planetary formation and the uniqueness of our solar system. They have spurred new disciplines, like astrobiology, dedicated to exploring the conditions under which life might arise elsewhere in the cosmos. Yet for all we have learned, the field remains young, and mysteries abound. How common are truly Earth-like planets? What strange and unexpected forms might alien worlds take? Could life thrive in environments radically different from our own? Each new discovery brings us closer to answers, but also reveals the depth of our ignorance and the vastness of the unknown. The explosion of exoplanet exploration stands as a testament to human ingenuity and the power of curiosity. It is a story of relentless pursuit, of overcoming technical challenges, and of embracing the unknown with open eyes and open minds. As we continue to chart the uncharted and peer ever deeper into the night, we are reminded of the words of astronomer Carl Sagan, who envisioned a universe brimming over with life and intelligence. The search for exoplanets is, at its heart, a search for ourselves, for understanding our origins, our uniqueness, and our place in the cosmic order. As the quest continues, each discovery brings us a little closer to answering the ultimate question. In the vast expanse of the universe, are we truly alone, or are there other worlds, other lives, waiting to be found among the stars? The journey has only just begun, and the possibilities are as limitless as the cosmos itself.